right, in section 3.1, we talked about measures of central tendency, mean, median, and mode, as well as some other ways of calculating average, like a trig mean or a weighted average. This section will be talking about measures of variation. First is the most basic measure of variation you can find, which is the range. Range is simply the difference between the maximum and minimum values of a data set. All you're really doing is taking your largest value minus your smallest value, and that's your range. What is the range of the list of numbers below? Just like we talked about in the last section, a good way to help you, a good way to help calculate stuff like this is to put your data in numerical order, especially for range. That would be really helpful. Now, it's not necessary, but you can still do that. But looking at this list of numbers, it looks like my largest number is 25. It looks like my smallest number is 6. So my range is going to be 25 minus 6, which is 19. That's all you're doing. Take your smallest value, or take your largest value minus your smallest value. Here's another example. A large bakery regularly orders cartons of Maine blueberries. The average weight of the cartons is supposed to be 22 ounces. Random samples of cartons from 2 suppliers were weighed. The weights, here are the weights below. So compute the range of carton weights from each supplier. So for supplier 1, here's my maximum, here's my minimum. So 27 minus 17, that's 10. Supplier number 2, also same thing. Largest minus the smallest, they actually end up having the same range. Now compute the average of cartons from each supplier. Well, again, just like we did before, we're going to add each of these up and divide by the number of values. In this case, it would be 5. So let's see, 17 plus 22, 3 times plus 27. That's 110 divided by 5. That's 22. Here, 17 plus 19 plus 20 plus 27 plus 27. That's, again, 110. So not only do they have the same range, but they also have the same weight. They also have the same average weight. Now, that usually doesn't really mean much, but there are ways for us to be able to choose which supplier that we want, without having, I don't want to say don't require the average, because the average is going to be required for variance and standard deviation. But point is, if your range and your average are the same for those 2 suppliers, there are going to be other ways that we can figure out which supplier to choose, which supplier we'd rather choose. Okay. So one of the big key topics in the section is on variance. Variance is the average of the squared differences from the mean. Now here we see this symbol, all right? Now in your notes, there are two main formulas for variance. This right here is a sample variance. You know how we take data from a sample? There's also a population variance. And the formula looks almost exactly the same. They look almost exactly the same, but I will go ahead and tell you the difference. Now, to find variance and standard deviation, there is a process this can be translated into a process so that we're not focused on memorizing the formula. We're actually more focused on memorizing the process, because once we know the process, then we'll actually be doing the formula without even knowing that we're doing the formula. So S squared here, that's the sample variance. This X sub I is a specific data value. Here, again, you saw this in section 3.1, the capital Greek letter sigma, that's a sum. This means that we're taking the sum of all of these right here. And I'll explain what that means in a second. And obviously, you've seen this before too in the last section. That's your average. That's the mean. Okay. N is the sample size, number of values in your set. Now, the difference between the difference between the sample and the population variance is only here, the denominator. Because this X bar up here and this Greek letter mu mean the same thing. It's the average. Okay? So when you talk about variance in your numerator, you're really taking the sum of all of your X minus your average squared, and then dividing it by n minus 1 or n if it's a population. The reason why we divide by n minus 1 for a sample is that it gives us some room for error, gives us some margin for error, because like we talked about with sample versus population, sometimes samples don't exactly represent the entire population. But if you're taking data from a population itself, then you would divide by the number of items that you have. Okay, but enough talk about the formulas. Let's go ahead and talk about how to find the variance. And as we go through each step, we're going to talk about what part of the formula that it's referring to. First thing you want to do is you want to calculate the average. Absolutely need to calculate the average of your set. Once you find the average of your set, then you subtract that average from every value in that data set. That's where this part of the formula comes into play. Once you subtract the average from every value in that set, then you want to square each of those results. That's where the exponent comes into play. Then, once you do that, you find the average of all the results from step 3, from this step. And that's where the rest of the formula comes into play. Remember, when we take average, we add them up, divide by the number of items. But remember, difference between sample and population is that you divide by n minus 1 instead of n. So if I'm looking for sample, if I have 10 items, then if I'm looking for variance, I'm going to divide by 9. But if I'm doing a population, then I'm going to divide by 10. Okay. So here's an example. Here's a set. We're going to look for the average. Okay. So I have 6. There we go. I have 6 values up here, which means that when I look for the variance, and I'm going to do this as a sample, when I look for my variance, I'm going to divide by 5. But when I'm looking for the average, I'm going to divide by 6. Okay? So try to remember this. When you take the average at the beginning, you divide by n. But when you take the variance at the end, you divide by n minus 1. Okay? So here's my numbers. I'm going to add all these up, divided by 6. So that's 3 plus 5 plus 6 plus 8 plus 8 plus 12. That's 42. Divide that by 6, I get 7. So with each value in this set, I'm going to subtract 7 from it. So I'm going to put all of my values in this first column here. 3, 5, 6, 8, 8, 12. Now I'm going to subtract each one of those by 7. So 3 minus 7, 5 minus 7, 6 minus 7, 8 minus 7, 8 minus 7, 12 minus 7. And it's okay for that second column to have negative numbers, because when we square all of these in the next step, then those negative signs will go away. Okay. So let's go ahead and go to the next step. We'll square all these values. So this will be 16, this will be 4, all 3 of these will be 1, and this will be 25. Then I'm going to go ahead and go to the last step. This is a sample, so I'm going to add all these up. 16 plus 4 plus 1 plus 1 plus 1 plus 25. And I'm going to divide it by 5, because that's n minus 1. So this is 25. 16 plus 4 is 20, so that's 45, 46, 47, 48, So that's 48 divided by 5, which is, again, this is S squared, is 9.6. 9.6. Now, there's one more step that we're going to add. We've already found the variance, but now we can go one step further and find the standard deviation. Basically, your standard deviation is a measure that calculates the distance from the mean. It's a measure of how far the data is from the center, okay? And it's real easy. Standard deviation for a sample is S, and then for a population, it's just theta. Now, wait a minute. Variance is S squared for a sample, and theta squared for a population. Huh. How do I find standard deviation? You take the square root of your variance. That's all it is. The standard deviation is the square root of your variance. So if I'm looking for the standard deviation of this set, I'm going to take that 9.6. I'm going to find its square root. And I'll go ahead and round that to 1 decimal place. That's 3.09, which rounds up to 3.1. Now, one thing we're going to learn about standard deviation is that the larger your standard deviation, the more spread out your data is from the center. The smaller it is, the more closely it clusters towards the center. So my average here is 7. My standard deviation is 3.1. So that's not really a large number. But if you look at the number 7 compared to these values up here, especially towards the center, the values are pretty close towards the center of 7. All right. Let's try another one. Now, to be fair, you don't necessarily have to put these in order if you're doing variance and standard deviation. Okay, you can, but you don't have to. It's not like median or mode where it really helps to put them in order. So we're going to go ahead and list our data in this here: 17, 15, 23, 7, 9, 14, 10, and 17. All right. Let's go ahead and find the average. Okay, so I'm going to add all these up. 17, 15, 23, 7, 9, 14, 10, 17. That's 112. I'm going to divide that by, it looks like I have 8 values, and I get 14. So I'm going to subtract the 14 from all these values up here. So 17 minus 14, 3. 5, this is a 1. This is a 9, negative 7, negative 5, 0, negative 4, and 3. Now I'm going to go ahead, I'm going to square all those values in the next step. 9, 1, 81, 49, 25, 0, 16, and 9. So now I'm going to add all these up. 9, 1, 81, 49, 25, 0, 16, 9. And since I have 8 values, I'm going to divide by 7. So again, I'm still assuming this is a sample. Okay. So 9 plus 1 plus 81 plus 49 plus 25 plus 0 plus 16 plus 9. That's 190. Divide that by 7. And I get 27.14 if I round to 2 decimal places. To find my standard deviation, I'm going to take the square root of that number, round that to 1 decimal place. 5.2. 5.2. So again, if you look at my average is 14. 5.2 is a little bit larger than 3.1. So the data around the center is a little bit more spread out than in the last example. Now you can also do this in your calculator. Let me show you with this example, previous example up here. So when you're doing this in your calculator, okay, what you want to do is you want to press this stat button right here. And when you press the stat button and you press edit, then it gives you a whole list of columns that you can put your data in. You can put all your data in these lists right here. So I'm going to do that with this. I'm going to do 17, 15, 23, 7, 9, 14, 10, 17. It's 8 total values. So all my values are on this calculator. So next, I'm going to press second and mode to get out of that. I'm going to press the stat button again, and this time I'm going to scroll to the right where it says calc, the calc menu. And I'm going to choose this first option right here, first variable statistics. And if your list pops up as L1, then we're just going to keep pressing enter until we get a list of data values. Now, if you have more than one list and you want to switch to say L2, you're going to press the second button and the number 2. And then voila, you'll get data for L2. We're going to go back to L1 and we're going to press enter until we get something that looks like this. Okay. Now, what does all this mean? Well, obviously the X with the bar is your average, which we said was 14. The sigma X is the sum of all your values. Sigma X squared is the sum of all your squared values, meaning that if I squared all those values and added them up, that's what I would get. Okay. So we don't really use, we're not really going to be using the sum of our values or the sum of our squared values in this. What we're really going to be looking at is my average and then these two things, SX and theta X. And the reason why is because, again, SX, that's your sample standard deviation. Theta X is your population standard deviation. Okay. And N is the number of values that you have. If I scroll down here, there are 5 more things on this calculator, but we're going to talk about that we'll talk about that a little bit later on. So you're not going to need to know these for right now. Okay. But that's how you do it in your calculator. And of course, like I said, standard deviation is a measure of how spread out your numbers are for the center. And we talked about how to find the standard deviation. What do these measures of variation tell us? It tells us that, obviously the range tells us about the difference between the highest value and the lowest value. At its basic level, it only tells us about the spread of our data. Well, of course, with sample standard deviation, it gives us an average of the data spread around the average. Again, the larger it is, the more spread out the data is about the average. The smaller, the less spread out. And variance tells us the square of your standard deviation. There's also coefficient of variation. Now, that coefficient of variation is important is because sometimes standard deviation is not necessarily the best comparative measure for data because it depends on the units of measurement, meaning that it's going to be a little bit hard to use standard deviation to compare measurements from different populations. So this is why we need coefficient of variation. Coefficient of variation expresses the standard deviation as a percentage of the mean. It's also known as CV. To find the CV, okay, to find the CV, we take our standard deviation, our sample standard deviation, and our sample mean, we divide it out, and we multiply it by 100%. So coefficient of variation is a percentage. So we divide our standard dev by our mean. That's going to give us the decimal form of that percentage. You multiply that by 100 to get that actual percentage. And because CV has no units of measurement, sometimes it can be a better way to compare 2 different sets of data. Here's an example. The Trading Post on Grand Mesa is a small family-run store in a remote part of Colorado. The Grand Mesa region contains many good fishing lakes, so the Trading Post sells spinners, which is our type of fishing lure. The Trading Post has only 8 different types of spinners for sale. Here are their prices. We're going to compute the CV of prices for the Trading Post. We're actually going to put this in the calculator so that we can find these a little bit easier. So again, press the stat button. We're going to edit, If you want to clear out a list, scroll all the way to the top of L1 or L2 or whatever it is, press the clear button and enter. And voila, you're ready to enter your new data. So I'm going to put this data in, 210, 195, 260, $2, 185, 225, 215, and 225. Okay. I'm going to leave my calculator, second mode. Then I'm going to press the stat button again and scroll to the right, and I'm going to choose one variable statistics. Now, because I'm still using L1, I don't need to change the list, so I'm going to keep pressing enter, and then there it is. Here's my average, which is 214, and my sample standard deviation is about 23 cents. Okay, so taking that into account, so our CV is our standard dev divided by our average, and I've rounded to 2 decimal places because we're talking about money. Okay, so we're going to divide all that out and multiply by 100. So 0.23 divided by 214 multiplied by 100, and I'm going to round this to 1 decimal place, 10.7%. So not really varied at all about the center. You can even tell that some of these values are pretty close together. But that's the CV. That's how you do coefficient of variation. Standard dev divided by average multiplied by 100. Okay. Last thing. There's a Russian mathematician named Chebyshev that came up with a theorem that says that, no matter what type of data you have, whether it's a population or a sample, a proportion of that data must lie within a certain number of standard deviations on either side of your average. Now, the theorem isn't necessarily important, but what comes after that is what is important. So we're going to call this correlate. We're going to call this a corollary of the results from Chebyshev's theorem. For any set of data, no matter what it is, at least 75% of the data falls within 2 standard devs from the mean in that interval. Okay, so that means that if you have, let's see, just to write this down mathematically, if this is my average, this is my sample standard deviation, then 75% of the data falls within this interval. Average minus 2 standard devs, and average plus 2 standard devs in that interval. Okay, that's 75%. At least 88.9% falls within 3 standard devs, and at least 93.8% falls within 4 standard devs. Now, later on, when we talk about empirical method or empirical rule, or anything that comes from that, we're going to be a little bit more specific about how much of the data falls within those intervals. But for now, you have at least 75 within 2, at least 88.9 within 3, and at least 93.8 within 4.